Welcome to the second section of topic 10, 10.2. We're going to talk about arc length, sectors, and tangents today. I want you to go ahead and look at these three questions for bell work, treat them as you would normally for bell work, and read them, see what you can come up with, or at least an idea, and then go ahead and answer. For number 2 and 3, the shaded section of this would be this piece right here. So this will be our shaded region that we're talking about. All right, go ahead and pause and see what you can think of. Hopefully you were able to determine number 1 for sure. So our shaded region is this guy, but number 1 says find the measure of arc AB. Arc AB is this piece right here, and remember arc measure is equal to the central angle. So this should have been 90 degrees. Number 2, how do we think that we could find the length of the arc? Now notice this word length. Length is a different term than measure. So length is a distance, and we know distance around a circle is a circumference. So you might have actually found it and calculated it, but you should be thinking that is a fraction of the circumference. For number 3, the area of that region, well, just as this arc length was a fraction of the circumference, this area should be a fraction of the whole area of the circle. So you might have actually calculated it, or you might have realized that 90 is 1/4 of 360. So by finding the area of the whole circle and dividing it by 4, that would have been accurate also. So let's keep going. This idea of arc length. So your length of an arc is simply just a chunk of the circumference. So I have these two formulas here where arc length is actually equal to x over 360 times pi times d. X is going to represent the central angle. So the central angle measure, or some of you might think of it as arc measure. Either way, that's what x actually is equivalent to. And then you can multiply it by either pi times d or 2 pi r, which are the circumference. So let's look down here. I'll walk you through this first one. Arc AD. We know that the measure of arc AD is 40, but if I wanted to find the length of it, so the length of arc AD, I would do 40 over 360. So that's representing the chunk of my circle. And then I'm going to multiply it by the circumference. I'm going to go ahead and stick with pi times diameter just to simplify this. So right now, if I look here, my radius is 4.5. So that means my diameter is 2 times that, which is 9. So I'm going to multiply this by 9 pi. Now I'm going to show you specifically how to put your answer in terms of pi. It's a skill you're going to need to have, and to the nearest tenth. So for those of you looking at this, you might be able to say, okay, well 40 times 9 pi, that's going to go in my numerator, all over 360. So some of you, if you're savvy with reducing fractions, go to town. I like to just kind of reduce away as I go. So if I look at this, anytime you have two numbers ending in 0, you can divide those numbers by 10, and the zeros will go away. So if I divide the top and the bottom by 10, I'm going to get 4 times 9 pi all over 36. Then I can think to myself, what else can I reduce? Well, I know 9 goes into 36. I apologize, I wrote 360 but said 36. And now I can look and say, well, 9 goes into 36 4 times. So if I divide the numerator and denominator by 9, 9 divided by 9 is 1, 36 divided by 9 is 4. So this becomes 4 times 1 pi all over 4. Well, 4 over 4 is 1, so my answer, the length of arc AD, is actually pi centimeters. Or if you were to round to the nearest tenth, 3.1 centimeters. Some of you might be thinking, whoa, what just happened? But just stay with me. The biggest idea is that arc length is a chunk of the circumference. Let's go ahead and try arc DC. So same circle. This time we're doing this arc. So if you will, we need to know what the arc measure is. Well, if this is a diameter and this guy was 40, this should be 140 because they should add up to 180. So arc DC would be the length of it, 140 over 360, times our same circumference, 9 pi. This time, you should end up with 140 times 9 pi all over 360. If you start to reduce now, you can think to yourself, well, I can divide by 10, okay? And then you might be able to think all in the same step, 9 over 36 is 1/4. So this gives you 14 pi over 4. We're almost there, but 14 and 4 have a common factor also, which is 2. So if you divide each one by 2, you're going to get 7 over 2. So our answer would be 7 pi over 2 centimeters. Or, because 7 over 2 is a nice decimal, you could leave it like this. These would be your answers in terms of pi. If they asked you to round to the nearest tenth and they didn't tell you to use 3.14, you would use the pi button on this. And you could do 7 times pi divided by 2, or 3.5. Well, I'm sorry. There should be a little pi in there. Okay? 3.5 times pi. You could do that also. And depending on, here we go, let's fix this. So then when you put that into your calculator, you get like 10.99 or 10.98, which would then be 11.0 centimeters. All right, you guys go ahead and try. Pause your video, see what you can come up with. Walking through this first one, arc CD is this guy. So if we're finding the measure of this arc, and notice it's asking us to round to, the measure of this arc would be 104. When finding the length of this arc, we're going to round to nearest tenth. I made it easy on you. So we would simply do 104 over 360 times, if you look here, our radius is 4, so our circumference would be 8 pi. So a lot of you are probably getting comfortable with making this your whole numerator. You can simply put that in your calculator, and once you do that, you get 7.3, and we don't know what the units are, so we just put UN for units. For arc AD, you can go ahead, A to D, notice you go directly A to D. We don't stop through B or C, we go directly A to D. We need to figure out the measure of this. So the measure of this, we know all the other ones, all the other central angles, so we would do 360 minus the 104, minus the 73, and minus the 43. So the measure of arc AD would be 140. Once you do that, now we can do 140 over 360 times our circumference of 8 pi, and if you put that into your calculator, you get 9.8 units. Last but not least, if we look at the last one, notice A to B to C. So I have to start from A, go through B, and then hit C. I can't go the other direction through D. That's not an option. So this time, we would add the 43 and the 73 for our arc measure, and multiply that by our circumference. So this would give you 116 times 8 pi all over 360. And if you did that in your calculator, you should get 8.1 units. So just make sure you have all of those. Okay, moving on. So now we're going to talk about the sector of a circle. Sector of a circle sounds like the word section, and that's basically what it is. Imagine a piece of pie or a piece of pizza. It's just a section of the whole pie or the whole pizza. So our sector is going to be what we call like a shaded region, kind of like what we had in our bell work. So this would be a sector of our circle. Notice we're still going to use x over 360, so we still use the arc measure over 360, and then this time we're finding the area of this thing, so we're going to multiply by the area. So this is just a fraction of the area of a circle. So let's go forward. Let's give it a whirl. So it says find the area of the shaded sector. Well, this is our circle from the last page. So the area of this sector would be 78 over 360 times our radius squared times pi, or pi r squared. So in this case, we would end up with 78 times 100 pi all over 360. You can go ahead and try to reduce this and put it in terms of pi if you want to. It's just a really large number. You get 65 pi over 3, or 68.1. And this time we have our unit, so it would be square centimeters for our answer. Let's go ahead and try this next one. The next one, our shaded region, or our arc measure, is 165. So for our area, we would do 165 over 360 times pi times our radius squared. So this becomes 165 times 9 pi all over 360. Now if you want to go ahead, this one's a little bit easier to put into in terms of pi, if you will. 9 goes into 360, so 9 divided by 9 is 1, 360 divided by 9 is 40. So this becomes 165 pi over 40. Now, if I'm looking at this, I'm thinking, well, 165 and 40, they both end in a 5 and a 0, so that means 5 must go into those numbers. Those of you who are comfortable with your division rules. So if you do 165 divided by 5, you get 33. If you do 40 divided by 5, you get 8. So your answer in terms of pi would be 33 pi over 8 square units. This is accurate because 33 and 8 don't have any more common factors. If you round it to the nearest tenth, this would just be 13 square units. Make sure you're comfortable with both. Go ahead and try this one, see what you can come up with. Go ahead and check your work here. So 59 over 360 times your area of 100 pi. I went over here and I started to show you the process for reducing it into simplest radical, in terms of pi. If you look here, you would eventually get to this answer in terms of pi, or this would be your answer rounded to the nearest tenth. Okay, let's try this one. I'm just going to set you up real quick before you get started. It says Chen uses circular corkboard to make 18 watermelon coasters. Notice they only show you one corkboard and they show you what one coaster looks like. He's going to make 18 of these. Well, if I were you, I'd be thinking, okay, I know my diameter is 8, so that means my radius is 4, but this 72, that means that I must be able to make so many coasters out of this one corkboard. Well, if you take 360, because that's how many degrees are in a circle, you divide by 72, you get 5. So that means that one corkboard is equal to 5 coasters. So just something to keep in mind as you proceed. Go ahead and try parts A and B. All right, let's look at part A. So we're using, Chen is using, he's painting one side of each coaster with special paint. Each jar of paint covers 200 square inches. Will one jar of paint be enough to paint all the coasters? Let's figure out how much paint he would need to cover one coaster. So that means area. So we would do 72 over 360 times the area, which would be pi times our radius squared. So we know 72 over 360, we know that 72 goes in 5 times. So this is the same thing as 1/5 times 16 pi, or 16 pi all over 5. But notice, this is the area of one coaster, and notice that I didn't round this number because they want to know how much he needs to cover all of the coasters. So If we now think about the fact that he's not making one, but he's making 18 coasters, I'm going to multiply this exact number by 18. This is why I didn't round, because if I round and then my area is wrong, I might actually tell Chen that he needs more or less, I'm sorry, he needs more paint when he doesn't. So 18 times 16 gives you 288 pi over 5. Now I can go ahead and put this into my calculator. You get approximately 181 square inches. So that would be the area of all of the coasters. So we would say yes, one jar, which is 200 square inches, is enough for Chen. Hopefully you got that. Let's go ahead and look down now at part B. Part B says he's now putting decorative tape around the edge of each coaster. So around the edge of each coaster means that we're finding this length here in order to figure out how much tape he needs for one coaster or for each coaster. We're not doing all 18 this time, we're just doing one. So that refers back to arc length. And our formula for arc length was the measure over 360, the fraction of the circle, times this time pi times diameter, which is the circumference. Well, we know 72 over 360 is 1/5, and then we have times 8 pi, or this would be 8 pi over 5. If you put that into your calculator, using the pi button, notice they didn't say use 3.14, you get like 5.026, or if we round to the nearest tenth, 5.0, and this would be inches of tape for each coaster. The next thing here is we're going to talk about the segment of a circle. The segment of a circle is kind of like if you're eating pizza and you don't like the crust. So if you're eating pizza and you don't like the crust, then you leave the crust on your paper, and that's what we're actually going to be finding the area of here with the segment. So we just went over how to find the area of a sector, which is like the whole piece of pizza. But now we're going to talk about how to find just the crust. So the process here, we're going to do the area of the sector minus the area of the triangle, which would be all the pizza that we eat. So let's go ahead and try this. If this is our first one, some of you might be thinking, well, I know how to find the sector, okay, but I don't know how to find the triangle. So really fast, this should say segment, my apologies. But if you're asked to find the area of this sector, we know that the area of our sector is just x over 360 times pi times our radius squared, minus the area of our triangle, so minus 1/2 base times height. Well, if I take our triangle, let's just go ahead and take our triangle and let's bring it down here. Let's think about our triangle for a second. If I want to know the area of a triangle, I need to know what the base and the height of the triangle are. Right now I'm given this, and I know that each angle is 60 degrees. But if I draw my height, that means that each of these tiny angles are 30 degrees. So this now becomes a 30, 60, 90 triangle. If you remember your rules, 8 should be the hypotenuse, double the length of the short leg. So each one of these short legs should be 4. So that means the base of our triangle, which is an equilateral triangle, is 8. And then our height should be 4 root 3. If you don't remember that, review those notes, or you can use Pythagorean theorem. So now I can go up here, and I can actually do my problem. So I can do area of a sector, 60 over 360 times pi times my radius squared, minus 1/2 times the base of my whole triangle, which is 8, times the height, which is 4 root 3. Putting this into simplest radical, in terms of pi, I keep saying simplest radical form, my apologies. 60 over 360 is 1/6. So this becomes 64 pi over 6 minus 1/2 of 8 is 4. This becomes 4 times 4 root 3. Now, 64 over 6, it's not a nice number, but they're both divisible by 2. So this could be 32 pi over 3 minus 4 times 4 is 16 root 3. This would be our answer in terms of pi. Notice we can't combine these. That would be what you would leave as your final answer. If you were asked to round to the nearest 10th, you would simply put that 32 pi over 3 into your calculator, subtract the value or the product of 16 and root 3, and you get 5.8, and this would be square centimeters. So your crust would be 5.8 square centimeters of area. Let's try again. Okay, so this time, same process. Area of our sector minus the area of our triangle. So our sector this time is bounded by this radius, so we're going to find this area of this whole thing. And then we're going to scratch out the area of this triangle, so we'll be left with our segment. So the area of the sector, so we would do 120 over 360 times our pi times our radius squared minus 1/2, base and height. Now let's think about our triangle. This time, if we have a triangle, and this angle is 120 right here, that means when we cut it in half, this is now a 60, 30, 90. Because we know it's isosceles. Okay, so we know that these two angles are the same. So this would be a 60, 30, 90. Same as we had before, but this time our hypotenuse is here. This would be our short leg of 2. And then this would be our long leg of 2 root 3. So this would be 2 root 3. So our whole base would be 4 root 3, because it would be 2 root 3 and 2 root 3. So I would do base times height of my triangle. Base and height have to be perpendicular to each other. So my base would be 4 root 3, and my height would be 2. So as I'm going ahead and solving for the area of this segment, I'm going to do 120 over 360. Well, 120 over 360 is 1/3. So this becomes 16 pi over 3 minus, well, 1/2 and 2 cancel. So, well, 1/2 of 2 is 1. So this would be minus 4 root 3. So this right here would be your answer in terms of pi. If you were to go ahead and put that into your calculator, you would get 9.8. Make sure you guys are actually doing the calculator portions, because you want to make sure that you're comfortable with substituting these values in. And whenever you use pi, use the pi button unless they say to use 3.14. All right, you guys go ahead and give this one a whirl. If you're cruising through this one, you should notice, I should say segment again. I'm going to struggle bus with that today. So if you notice here, our triangle is a right triangle. So no 30, 60, 90s or anything like that. This time you know that the two radii are congruent, so the base and the height are actually the perpendicular radii. So the area of our sector, we would do 90 over 360 times pi times our radius squared minus the area of our triangle, 1/2 base times height. 90 over 360 is 1/4, so this becomes 100 pi over 4 minus 1/2 of 10 is 5, 5 times 10, or 1/2 of 100 is 50. So in terms of pi, your answer would be 25 pi minus 50. This would be your answer in terms of pi. If you rounded to the nearest 10th, 25 pi minus 50 gives you 28.5, and this would be square feet. Hopefully you're pretty comfortable with that. If not, you'll get a little bit more practice. Okay, definitely make sure you're comfortable with area of a sector and the arc length. All right, last thing, this is literally just a little bit of review of what you guys already know with Pythagorean theorem and just basics solving of equations from previous knowledge. But a tangent line, like we covered in 10.1, is a line that touches a circle exactly once. It follows a log, extending in both directions, and it makes a 90-degree angle or it is perpendicular to the radius. So using that, you guys just need to be able to apply Pythagorean theorem. So if you look here, if we have OT is tangent to this circle R, that means this is 90 degrees. So 5 squared plus 12 squared would be this whole thing, x squared. And then algebra happens, 5 squared, if you take the 25 plus 144 and you square root it, x gives you 13. So just a quick review of how you can apply Pythagorean theorem. Next, it's a little bit more complicated, but we have OT is still the tangent line. We have x now is our radius from here to here, and then from here to here, and we're going to solve. So we set up our formula, x squared plus 12 squared equals, now this whole thing, a lot of people are going to put 8 times x, but it's not. You don't multiply, you just add them together. So this would be x plus 8 squared. Algebra happens, x squared plus 144. Now, those of you who are thinking, oh, x squared plus 64, be careful. This is actually x plus 8 times x plus 8. So this would be x squared plus 144 equals x squared plus 16x plus 64. Okay, your x squareds are actually going to cancel. And then if you subtract the 64 from the 144, you should get 80 equals 16x. If you divide then, you get x equals 5. So the radius of that circle is actually 5. Last bit of new material, if you will. If you have two tangent lines, so this would be tangent and perpendicular, this would be tangent and perpendicular, these two tangent lines are actually equal to each other. And this is now a four-sided figure where we have 90, 90, and then we have two more angles. And if you remember back to, I forget what topic number, but quadrilaterals, a four-sided figure means that angles sum to 360. Just a little fun fact there. And then down here it says find the value of x. Well, if these are both tangent lines, that means that this piece is equal and congruent to this piece. So 32 would equal 3x plus 5. Algebra would happen here, and x would equal 9. Give these three a whirl on your own. Go ahead and pause your video. And go ahead and check your answers here. So for number 1, they asked you if the line KJ was tangent. You basically just needed to see if it fit into the Pythagorean theorem. Up here, it did not, because 36 plus 81 is not 100. So you would say that that KJ is not tangent to circle P. Number 2 was just like an example that we did. You should have gotten x equals 7. And then number 3, using that idea that four-sided figures add up to 360 degrees. If you take 360 and subtract the 90, the 90, and the 135, you should have gotten 45 as your answer. Okay, last thing here, your homework is actually a review for a quiz that is coming. Okay, you're going to have small quizzes throughout this unit to try to chunk the material and help you with understanding of smaller bits versus a whole topic. So you're going to complete the review, you need to show work, everything. Attach your work and then turn that in, attach your notes also, okay, to the assignment in Teams, and I hope you guys have a very productive day.